Club to order. Recording in progress. Thank you very much, Chris Mayer, our Zoom chairperson. Let's kick this meeting off with industry news. I think one of the most interesting things the past couple of weeks is probably Tesla's announcement. Let's see here, I think I got it going. Let's see, I've got the sound off on this because I got the sound on my other phone. But anyways, we'll just play the video. And we've already talked about this on the mailing list. I think the interesting thing here is that they built this in 1 year. They're using their own components and they're using the autopilot computer from the cars. And so let's scooch it up a bit. Other humanoid robots are ahead of this, but pretty impressive for 1 year and using their own components. Any other industry news anybody want to bring up?
This is Scott. RosCon was last week. RosCon was in Kyoto, and there were all kinds of things in my Twitter feed, just really folks doing interesting talks on the state of the art of slam and different kinds of ways they're, just all kinds of different stuff. I can't think of anything specific off the top of my head, but I would encourage anybody to look up RosCon Kyoto, and I think all the different talks are there, and you can watch them. And it's not just about Ross, but it's robotics in general, really more geared towards industry rather than the homebrew types. But it's really neat to see what everybody's doing.
RosCon this week was very good. So I found this one in the news, the tentacle robot. Get rid of the advertising here. So this is pneumatic tentacles that, I guess they suck in or blow out, and then it's able to grab things. If they only had 1 or 2 of these, it really wouldn't be worth much. But apparently you use, a dozen or so, and then you're able to pick stuff up and move it around. Looks pretty creepy. But that's the tentacle robot. Looks like that's coming from Harvard. I put the link in the chat if somebody wants to look, if you want to look into that further. What else? What else you got for industry news out there?
Yeah, Kent, this is Alan. I saw something in passing, and I'm sorry I didn't bookmark it, about this ex-Google guy who's has a startup with a face sensor. It's a camera with embedded AI for face recognition.
I saw that too.
Yeah.
Why don't you find the link for that and put it in the chat when you get a chance?
Yeah, okay. I thought that was interesting because they were like supposedly making it available for developers.
Yeah, it looked like a reasonable price, and it's all in one, just doing the face recognition and going from there. So that might be useful. What else for industry news and robotics? I found this one, speed folding. Looks like an ABB robot. And I think this is coming out of Berkeley. And if I recall correctly, this is sped up 3 times. But PR2 could fold clothes, but it took it like 20 minutes to fold a towel. I think currently, and I've got an article in here, I'll post to the link also, or the chat. What do they say? Let me find this article. I think PR2, it took it like 40 minutes to fold a towel or something. Currently robots, let's see, do 30 to 40 garments per hour, but this guy apparently is able to do 3 to 6 garments per hour, which is not, blazingly fast, but you leave it in a room with the wash, and within a couple of hours, all your clothes are folded. So that's something coming down the pike. I'm gonna post a link to the article on that. What else we got? Robot industry news. Anything interesting out there?
Well, there was a
All right.
closure. Argo AI, it says, is shutting down. The self-driving company backed by Ford and VW.
Okay.
Interesting.
Any idea where Ford and or Volkswagen are going, from here? I mean,
You said they shut.
Argo AI, yeah, and will not continue on its mission as a company. Many of the employees will receive an opportunity to work on with Ford or Volkswagen, while employment for others will come to an end. So I guess they're taking it into the company. Ford has its own group, but the deal with Argo is over.
yeah, I'm reading a quote here. Ford said in its third quarter earnings report, a strategic decision to shift its resources to develop advanced driver assistance systems and not autonomous vehicle technology that can be applied to robotaxis.
Mm.
Yep, getting real time. What else? Any more industry news out there?
I just added to the chat that one thing that came out of RosCon was that the announcement 2023 RosCon is going to be in New Orleans next year rather than overseas. So I don't know. Right now, I'm thinking about doing it because it seems like it'll be a lot of fun.
That does sound like fun.
What's going on, Camp?
I've been to New Orleans on an average garden variety Tuesday night. I could not imagine it during Mardi Gras.
Oh,
Being there with RosCon, though, that might be fun.
well, I got one artist friend of mine that's really scared right now. Apparently, there's some AI out there. If you describe what you want, it can generate the image for you.
Is this industry news?
Apparently so. It's a program out there. I don't even know what it's called. He told me yesterday. Basically, you can type into it, describe something you want to have generated as an image.
Yeah,
Image or
Dolly.
image
Dolly
or,
from
yeah,
a
image
while.
or photograph, and it will generate it for you. Give you a bunch of choices. You can
Called
select
Dolly.
yeah, there's a few of them.
Yeah, well, my friends and ours. If he
Yeah.
feels like it's putting him out of business now because of that.
Yeah,
Again, AIs are powerful. They're very clever. They can analyze a lot of images really, really fast, but creative, they're not.
there's also Mid-Journey. Mid-Journey is a
Yeah, that's the one he's talking about.
Mid-Journey is a free one, I think, technically.
Well, basically, it shows an example, basically, either typing in something for a magazine cover or whatever, and then generated something completely from scratch.
Yeah,
But
yeah, I've used
based on hundreds and thousands of images that's got stored in it. It's not doing anything creative. It's just comparing, trying to put something together based on what you said. Drawing,
Right.
printing, photographing, it's not.
And it's based on millions of images scraped without permission too, in all the cases. So
Right,
there's
it's
going to
just-
be some big IP battles coming up about them.
It's Just like
Oh,
what I
that's a
saw as an example on Americans Got Talent, they were able to use AI thing to generate something to a stage that literally bring Elvis Presley back to life. What they did is use the technology to scan
So
someone's.
are you talking?
Go ahead.
Not literally.
This is real time. What I'm trying to say was on American Got Talent, a demonstration of some things.
Are you
Basically,
talking about the?
basically took an actor that sounded like Presley, scanned his face. They had cameras in front of them on stage there, and the minute they projected it on the screen behind it, the guy suddenly looked just like Elvis Presley, sung like him, moved like him, looked just like him on the large video screen, even though it wasn't him. It was on Americans Got Talent.
So I
That's what-
see Chris
Are
Palmer's
you talking about?
Chris Palmer's posted about passive wall tracking for rotorcraft tilted and ducted propellers using proximity effects. Let me share my screen again. And here it is. So apparently this is following the wall.
Now, what is that I'm looking at?
This is a drone that's following the wall, following a wall, using rotorcraft with tilted and ducted propellers using proximity effects. There's a link in the chat.
Oh, by the way, if you guys are interested in that technology I just described with an American company is called Metaphysics.
Put a link in the chat.
I will in a minute.
All right, take your time. All right. Any more industry news out there?
Yeah, I found that sensor you were talking about, Camp. Actually, I found it on your own Facebook feed. The video with AI enabled. I posted a link to it. $10.
We have a Homebrew Robotics Club Facebook group. So if you're in Facebook, be sure and join the Homebrew Robotics Club on Facebook. You can also send me a friend request. I get all my news from Facebook. Any more industry news out there? Robot industry. Okay, let's move into club news now. First off, presentations. Presentations are everyone's job. Stephen Williams, are you out there? Stephen's our program chair. He's graciously agreed to do that again next year, so we'll see what that brings. But presentations are everybody's job, okay? Not just one person. So if you want to do a presentation, or if you know of someone that should be doing a presentation with the Homebrew Robotics Club, either contact me or Stephen Williams. Don't book them yet. Just make sure they're okay with doing a presentation, and then get with Steve and I, or we'll line them up for the general meeting. And while we're at it, let me just give a shout out to Al Magales, who's at Maker Nexus and does a heck of a job as our webmaster. And so our general meeting, which is what you're at, is the last Wednesday every month. We like to call it the Ultimate Wednesday. And then we do the SIG, the Special Interest Group. I call this the Builders SIG. It's the penultimate Wednesdays, okay? And then our business meeting is the first Wednesday of the month. So that's going to be October 5th, and that's where we talk about the business of the Homebrew Robotics Club, in particular presentations. So presentations is everybody's job. And so thank you very much, Al Margales, for everything you do. So elections are next month. And we have, let me share the screen again.
Sorry, I'm on a weak connection here.
Sorry.
That's okay, Suresh. So these are the officers for 2022. Anybody and everybody's welcome to run for any office, but there's president, secretary, treasurer, program chair, sergeant at arms. Now, Chris is in Southern California, so he does the Zoom. He's also our Zoom chairperson, but we'll be looking for somebody physical on site there. Maker Nexus to help Al and Dan keep the crowds under control there. And of course, our sensational webmaster, Al Margolis. Again, thank you very much, Al, for everything you do. Okay, any more club news?
Yeah, I just wanted to stress that we do need someone to step up to be the new sergeant at arms. It's a relatively easy position to take care of, but it's for someone who will be going to the in-person meetings.
Yeah, sergeant at arms is kind of a physical thing. And also, Al, I'm just noticing this, is the first Wednesday of the month is October, okay, November the 1st will be our business meeting. And so I would say November the 2nd is the first Wednesday of the month. So we'll get that updated. Anyways, first Wednesdays, business meeting, penultimate Wednesdays, the builders SIG, and then the last Wednesdays, the general meeting. Along the way, we also have a Ross discussion group on Tuesdays, and every other Thursday, there's a voice intelligence group, but you get the links for these things through the mailing list. Everybody's on the mailing list, right? If you probably got here because you are on the mailing list, but if you go to our homepage and join our mailing list, it's a Google group. This is where all the information comes through. So you want to join the Homebrew Robotics Club mailing list. What else? Any more club news out there? Okay. Moving right along. What I need help with is anything somebody's working on that's just banging their heads against the wall and needs help with something in particular, robot building wise. Everybody's building projects are going along swimmingly, got all having no problems or anything. Marco and I had a good discussion the other day. I got this $70 Ubuntu Chromebook, if you will, and I install Ross and Lino Robot, and all of a sudden I'm down to 200 and then 100 megabytes of space. So it's screaming and yelling at me. Anyways, I want to add another SSD card and try to get all the installation on that. I think it's going to involve some sim links and stuff, but anyways, I'll be trying to overcome that and probably be posting to the mailing list on it. So that's something I'm working on. Any more what I need help with?
Don't need help yet, but I have been working for the past week or so to port Robot completely over from the Jetson Nano to a Raspberry Pi 4. I started with the Raspberry Pi 4 originally with Robot, but I wasn't happy with frame rates I was getting on deep learning inferencing. But now that I know how all that works, I realize I don't need great frame rates. So I'm putting the Jetson away for now. We'll see how it goes.
Scott Monahan, ladies and gentlemen. All right. Creator of Robot. Any more of what I need help with? All right. Let's get on with the best part of the meeting, Show and tell. Who has a show and tell?
I have one, George.
George Taylor, you're on.
Oh, okay. Okay, so I showed part of this last month, but I said I'd come back and demonstrate things actually work. So what I have here, everybody seeing this?
Yeah.
Okay, so explain it a little bit more. This is what I consider to be a homebrew CNC machine because it was basically scraped together from parts and repurposing them for my particular use. So let's see how long it takes this thing to come up. Okay, so of course, the thing that drives this is I use a Linux CNC for my computer to drive the controller, and to develop the various G codes for this, I use Fusion 360. And this is just a little test object that I have.
We're just looking at your, we're looking at your Windows window, George.
Oh, let's see. Yeah, so are you seeing are you seeing image 0546?
Well, no, we're looking at your folder. We're looking in your videos folder.
Ah, I see. Okay, you have to do that. Okay, just a minute. You have to do that all at once, I guess.
I usually share my whole screen, and that way whatever I have on the screen gets parlayed to the Zoom.
Okay, so if I stop share.
There you go. Yeah, go ahead.
Okay, I'll stop share. Now, let's see. I have to go back and okay, I can figure this out.
Yeah, you might go share screen and just share the whole screen, and then whatever you have on your screen, we'll see. Don't have anything you have on your screen you don't want us to see on there.
Okay, so let me go back and see if this comes up. Okay, but then I can't see I got to lower it a little bit so I can see my thing to see my share screen. Okay, well, let's just try this and see if this works. Okay, so are you seeing the?
We see your computer now.
Oh, okay, you see it. Okay, so this is what you see here. So it's kind of like a typical CNC. This is what the Linux CNC looks like. You can't see all this stuff over here. Now, let me go then to get out of that one and go to this one. I showed this last time. This is the controller with the lid off. Okay, so these are all these are components I picked up at the electronics flea market. So this is the 24-volt power supply, 5-volt, and then there are these are the 3-axis controllers. And then I use 4N35 optical units to isolate from the parallel port. This actually uses the parallel port. Okay, so now for the actual demo. Okay, so let me get it going here. So now I think Chris, watch this and see if you think, let's see, this qualifies. Let's see, let me get it running.
You're going for an ARMBot challenge, right?
Yeah. So let's see if I can I got to get this running on a video. Oops. Just a second. Let's see if I can get the video to work. Oops. Okay. So I got the video running, I think now. So let's see, I got to share screen again. Okay. Okay, you're not seeing, there it is. Okay, here we go. Can you see that? Okay, see
No.
it moving? So that
No, no,
qualifies
no.
as movement, right?
We're seeing your face. I'm not seeing the, are you still sharing your screen?
Yeah, I thought it was. Let's see. Is that showing the,
Now play your video again, okay?
you're not seeing the video?
We are seeing the video,
playing.
yes.
Okay. Okay, so let me go back and start it over. So let's see. So you can see, let's see, I get that to go back. Yeah, let's go back to the start. So there's 0, 0. Okay, so it automatically turns on the router. Okay, and then this is only a 4-inch by 4-inch table. So you can see that's the y-axis, going up on the y-axis, picking over on the X. Okay, now it lowers it to the wood. So there it's starting to cut out that shape. It might be able to drive a little faster, but I find slower makes cleaner cuts. So anyways, so I did get this table at the flea market. I think it's amazing. I got this table for 20 bucks, complete with the stepper motors. So
It was a CNC mill, even as you bought it for 20 bucks at the flea market, right?
well, no, not quite. The only thing that I bought at the flea market was the table, this part of the table. So then I built this other part. Let me get out of this. So that shut this thing up.
George, what you did is very impressive. I'm impressed. I like
What's
what
that?
you did. Said what you did is very impressive. You did a very good job. I like what you did.
Yeah, that's my second CNC to build. The other one I have has a bigger table.
Mhm,
And so I can cut out larger parts.
mhm.
But I've never actually tried to cut, say, aluminum. But you know, part of my future plans, I would really like to build a metal Z-axis, something to constrain the Z-axis. If I built that in metal and hooked it all together, I probably could do that. I think this one, though, it probably will be suitable if I can get it aligned properly
Mhm.
for etching printed circuit boards.
Oh, yeah. A friend of mine
Can
has
you,
already
can you
done
put your
that.
video, can you
Yes.
put your video up one more time, George?
Let's see. Okay, hang on just a jiffy.
Don't forget to click optimize for video because it's kind of slow otherwise.
Yeah, can't be.
Oh, where is optimized for video?
When you hit the share screen, it's in the bottom left little box.
Okay, bottom lid. Oh, optimize. Oh, okay, there, I'm learning. Okay, let me get it going again so I can see something to share.
Share your screen.
Okay, just a minute. Let me get it running. I think you got to get that going. It takes a little bit to get it to come up. Okay, there it goes. Now, share screen. Oops, where is it? Okay, I need to, it's
The
running.
bottom
So
of the Zoom.
just a second. Here we go. Okay, optimize.
Yeah, you're not sharing your screen.
Just a second. Here we go.
That's a heck of a motor you got there.
It's a regular router. It's a Sears router. So how do you like my clamps I have for holding the router? Those
So this is
are,
a router motor that you just happen to have?
No, I remember, okay, I'm gonna stop this so we get rid of the noise. Do you remember, hang on a second, let me kill it. Do you remember that I had was given that large CNC that I gave away?
Go ahead.
So I bought that router to fit that CNC. It didn't come with a router. So then I had a router available. I have a bigger router, but this one's a smaller router. Anyway, I adapted it to run this one. So it's got plenty of power, I guarantee you.
The stepper motors and so forth, was this already a CNC mill or did you
No.
create the CNC
No.
mill? from
The
scratch?
only thing that I got that was, a commercial thing was the X and Y axis table. Okay, but it was just, with loose stepper motor windings. I had to figure out, how to get the stepper motors running, build the controller, and then get the Linux CNC running on a computer, hooking that all up, and then making some examples with Fusion 360. So I consider it to be pretty much of a homebrew CNC.
A question from Ryan in the chat. What was the X and Y table from?
Beats the heck out of me. It was from the thing I mentioned last time, for those of you who weren't here. I went to the electronics flea market in Sunnyvale. This is, several years ago. And there were some guys there unloading one of those big trailers. And so I picked it up. I just wanted the stepper motors, I thought, right? Then I went, oh my gosh, that's a regular XY table, right? And I said, geez, I hope nothing's wrong with it. So I held the thing up and I hollered across to the guy who was about 20 feet away from me. And I said, so what are you going to ask for this thing? And he said, what is it? And I said, oh, I just want the stepper motors. And he says, oh, how about $20? Now that thing is, a machined professional table. So
I had a beautiful one like this, similar. I didn't get to look at yours too close. It's probably not the same. I gave to the Hacker Dojo and they threw it in the dumpster when I wasn't around.
Wow, you're lucky.
I was upset. I was pretty upset really, because I donated it hoping somebody there would find it, because it's been laying in my storage for like 20 years.
Oh
I
my
got
gosh.
it from some microscope project and then they threw it out.
Oh, you should have thrown it my direction.
So, well, this has happened like 5 years back or something, maybe 6 years ago.
Yeah. Oh, geez.
Back on Fairchild.
Anyway, I tend to be a tools builder, and I need to take up some projects to cut with this thing. I need to work on the precision more. But it's been a fun project.
You're currently cutting wood, but you want to use it for making circuit boards?
Well, I say, yeah, probably. I think that's probably one of its more ideal uses would be to actually etch the traces for circuit boards. It's only 4x4, so I've got another one to cut bigger pieces. So
Very good. Very good.
Okay.
All right.
Okay. Did I qualify for an arm movement?
Unfortunately not, because it was not an articulated hierarchical model arm.
Well,
So sorry about that.
With the ArmBot challenge, you've got to build a robot arm that waves or moves, pick up an object, move it to another location, or pick up an object from an unknown location. But you know what? And Chris, you can call it. I would definitely give him at least a phase 1 run what you brung.
So I already had, I'd had a robot arm I brought to the meeting. You remember I had, a couple of different ones, but noticed those I didn't get credit for those in the records.
Well, that and $5 will buy you a medium coffee at Starbucks.
Anyway, well, this has been a fun project, so I
well,
still consider
it's definitely a run what you brung finished robot. So you got phase 1 and run what you brung. And so, get two more things on there and you have a phase 3, run what you brung.
Yeah, you know what I could do is put a little something on the table. So I could route it over, drill a hole in it, then pull it across the table. Okay,
don't
I'm
know.
taking enough time.
Chris is pretty tight. You got to catch him in a good mood. He's our official certification aider.
Okay, no problem.
What else we got for show and tell? Well, I got something. It is Halloween after all. Let's see here.
We'd expect no less.
Yeah, you'd be disappointed if so. I've got Sammy. He's the latest in a long line of skeletons. He's ready to go. Let's see here.
Are you the animator too?
I need to be playing some spooky music. Maybe I can get a phase 1 for this guy, Chris.
Oh,
Well,
that's cute. Was that on an RC base?
Run what you brung. That's a given.
Did you ask a question, Tim?
Is that running on some sort of RC base that you bought
Yeah,
somewhere?
this is all radio control. Basically, I've taken a skeleton, store-bought skeleton, and I just
Right.
articulated it with standard servos, and he works pretty good. And then everybody knows Rocky.
Well, if you put them in a black space there, you look really creepy.
Actually, let me get him packed up
Okay,
here.
so both of these are RC things of some sort. What did you use for the base? You used something that was already there? Or
The
you made-
base, it's electronic speed control. It's
No,
electronic.
no, I'm talking
speed
about the
control.
wheels and stuff.
Right. The wheels are radio control. It's a electronic speed controller like in RC cars.
You're not
You
answering my
control-
question.
What's
I
your question?
understand, I understand that, but what are you using for the motors and all that sort of thing? How you're
Well,
controlling
the
it, I
mo-
understand completely.
The motors are from HR. I forget the company name, but it's basically a gear motor. It's a gear motor
Oh,
controlled
so
with
you bought all this surplus and
yeah.
$5 of PVC tubing later, this is what you got.
Yeah, well, and actually this base is from John Erickson and
John Carlini.
John Carlini. Thank you. If I can get his arm in the right position here. There he goes. So there's Rocky. So these guys will be trick-or-treating, of course.
Well, no, they'd be scaring people away from trick or treating at your house, but yeah. But yeah, I get the idea.
Fun stuff.
I don't know if I'm
What
gonna
else-
have time to
what
put
else
something
for
together
show
for
and tell?
Halloween.
I've got one more on the bench here. This is my brother's skeleton. I've got him. He needs some jaw surgery, but I've got servos on him with ultrasonic. So when you walk up to him, he wakes up. He needs some jaw surgery.
Oh, well,
But
way
anyways,
it goes.
Halloween's on Monday.
Yeah, next Monday, actually. Let's see if this still works.
You gonna show us something, Tim?
Well, can't put the whole costume on, but I can turn the effect on, see if it's still functioning. Yeah, looks like
We're
one of my
hard to
battery,
impress, but easily amused.
looks like one of my battery packs came apart.
Get him in the middle of the camera.
Oh yeah, with the voice garbler too.
Yeah, well, I can't, it's hard to put the whole darn thing on.
Yeah. The eyes and the voice.
Yeah, the mouth moves to a microphone I have inside the mask and the eyes
the
are just
mouth.
randomly blinking, but it's hard to see it in the bright light here. It's randomly
Very
looking
nice.
around.
Very nice.
I call him the whole costume. I call him like my techno wizard costume.
Very nice. Thank you very much. Tim, what else? Somebody else got something for show and tell this evening?
All the other stuff I can't show you because it's top secret.
Not, you'd have to kill us, huh?
Yeah, and you're nice people. I don't want to do that sort of thing to you.
Anything else for show and tell this evening?
Got a new costume I just got in. I haven't had time to try it out yet. We'll see.
All right.
Batman
Without any-
Beyond.
Without any further ado, let's move on to the main portion of the program. Is robot builder extraordinaire Jim DiNunzio with the origin and chronology of Big Orange. Jim, take it away.
Thank you, Camp, and that's a very very nice compliment to call me that. I still consider myself a up and coming roboticist. But yeah, so Orange has been a long-term project, and you should see the screen now. Oh, it
Yeah,
says
sorry,
participants.
I don't understand, but yes, there are Orange. It's been a long-term project.
No, Orange is listening, but he may respond because
Sorry, I don't understand. Is listening bucket attack?
I may have to shut him up.
that's awesome.
Because I'm saying his name a lot. Oh boy.
Might start responding to you.
The future's going to be weird.
Yeah. Yeah, so
The future is wake words.
Hey, Orange, transfer funds.
oh yeah, that's the other thing is hold on a sec here. Yeah, my next you'll see in my future work is to add the wake word. In fact, that's my next thing I'm going to be working on is a proper wake word. Although since I'm saying the word orange now, it's you know, I would be saying the wake word. So here's so Orange started from or is built. Let's just go from the build side. Orange is built with a couple of main components. The first one is the home care robot HCR platform by DF Robot. You can see it here, which I bought later after the initial part. So that's the base that I'm using. The initial robot actually was the initial part was a fully fledged navigatable robot called the SlamTech SDP Mini. And I'll show you all the prices that I paid for these, but just these are the two most expensive pieces. The orange one at $530, and this one's about $500. This one, although you always buy things on Black Friday, you may get 20% off. So this little robot is a from SlamTech, a Shanghai company who I've been dealing with for 3 years now, tech support and all that. This was a complete SLAM solution with an RP LiDAR A2 as part of it, plus a board and a breakout board with GPIO and sensor capability and motors and everything. So you couldn't buy these individual parts for less than that money, and especially that LiDAR. So that's So Orange has really, I guess, 5 or more levels. The first level, so now we'll go over the hardware, and then we'll that's all on the HCR portion of it. And I'll talk more about spend a significant amount of time on the SDP Mini, the Slam Tech technology that this whole thing is really based on. So this shows you the first level. It's got the motor controllers, the 12-volt motors. I mean, motor controller, single bump sensors and sonar sensors that I've mounted there. Those are your standard sonar sensors that I currently am not using. You don't really need them. And with SLAM from the LiDAR really does a pretty good job. Although I may bring them back to see if I can improve the performance because the sonars weren't working that well. The LiPo battery brick I have is a 12-volt and 5-volt dual supply. And then the rear charging connector, which I had to fabricate myself, design and fabricate in 3D print. And I'll show you all the 3D printed parts. By the way, if anybody has a question, raise your hand using using the online Zoom raise, or just speak and let me know. Glad to take questions anytime. So this is the level 2. Level 2, the main part is the breakout board. This breakout board is I'm going to go into more details, but this is the microcontroller STM32 that was part of that SDP Mini. So all the parts of the SDP Mini were pulled apart, and well, the boards anyway, and the LiDAR were saved or were used in this robot, and the motors are and the little platform that's in storage.
Jim, you're saying STP Mini. What are you saying?
SDP Mini, this thing, you see that? This is the SDP
Yeah, okay, I see
Mini.
it now. I see it now.
So if I'll refer to this as the Slam Tech robot, if you want to call it that.
Okay, and I just put a
How
link
much
in
did you
the,
pay for that?
This is $500.
yeah, I just put a link in the chat for that.
Now there's not too many of these left, and they're not really. There's a support for them is kind of, I think, as far as updating the software, maybe over, but certainly the LiDAR is still good. The A2, and it's a good platform, and I have a lot of support. I have a lot of experience with it, so if you do get one, I have a lot of information and old firmware and all that stuff. But it has a lot of good parts to it, and it can be used. I used it for a couple of years just as a robot itself, driving it around. The key thing about that robot is that it's designed as a reference robot that you can take it apart and build your own robot and reset all the size, the dimensions of everything for you that your robot measure, and put that into the firmware of this STM32 board here. So that's what I did. And in fact, if you buy this HCR orange platform, then there's even more help to do that online. It still exists online. So level 2 is the breakout board, power rails, and now we start getting into the cameras. The OAK-D for obstacle avoidance is on this level. That one's just used to send to broadcast, or to, I guess, publish depth map data 10 times a second to the SLAMware core. And I'll tell you about the SLAMWare core in a minute, but the SLAMWare core is this, if you can see my mouse, this this card here that runs a full Linux system and is basically a black box to me, but I have an API to it to do all sorts of things. And then you have your audio speaker amplifier in the back there, and I built a little tray for it there. So this is where you see, now you recognize this piece of the this is a piece of the SDP Mini that now lives on my robot, and I just left that part of the top plastic, the top cutout piece there to mount the LiDAR, to keep the LiDAR on there. So that's level 3. And that's deliberately kept pretty sparse because LiDAR, even though it has all these little poles in the way, the LiDAR works pretty well. So now level 4 is the Latte Panda. This is the brain of the operation. It's a full Windows 10 computer. It's an SBC, single board computer. Celeron processor, 4 gigs of RAM, and quad core. It's not very powerful, but there's actually a new one out now that's even more powerful, this Delta. And there's an Alpha too, which is I think more powerful. But these are good single board computers, and it has a Arduino built into it. So you can, and I use that in mine as well. So it's a dual complete system plus microcontroller. And here's the 7-inch touchscreen mounted with 3D printed parts. So that's an invaluable addition to have a screen on board. Now, the next level, we get to the really good stuff, I'd say. Some of my favorite, the best sensors. We have the OAK-D for vision and depth on the top, which is mounted with a pan tilt standard hobby servos, upgraded from tiny 9-gram servos that were drooping due to the weight of the OAK-D in the past, in an earlier version. And we have the re-speaker microphone array, which really helps the vocal recognition system, removing noise and providing direction data for where the sound is coming from, as well as your millimeter, and then the millimeter wave radar sensor I recently added, which is kind of a fun side project I'm still experimenting with to see what good I can get out of it. But there's a couple of videos or at least one video, one or two videos where Orange can see through a wall that there's somebody there. So, or at least a wooden table, or a wooden door. It can't go through too much wall, but its radar goes through a fair amount. Now here's the other hardware, the charging station. So you might recognize the bottom part is actually,
it looks familiar.
a Nito BotVac charging station, which you'll see was one of my eureka moments that led me to be able to get to implement or build Orange's solution for charging. And the other weird looking thing is the charging pile, which is 3D printed on the top there. And that was designed by Slamtech, well, they gave me the 2D draft of it, like on paper, and I had to figure out, and the dimensions, and I made a 3D rendering of it to actually use it. And that is for LiDAR acquisition of the charging station. I'll talk about that a little later. So now, maybe I should pause a little bit. Cool.
Wow.
Let me know if I'm going too fast or too slow.
That looks really
Hey,
cool.
hey, Jim, your millimeter wave radar, what do you pay for that?
They're like $30-$40 or something around up to $50, not very much. There's a new one out that's better. It's 60 gigahertz instead of the 24. So, and they're better. They're from Seed Electronics, which has these things.
You were saying something about it seeing through walls, were you?
Yeah, so this is millimeter wave radar. It can go through non-metallic objects up to a certain distance, obviously.
But aren't you using it to detect obstacles or objects?
Yeah, I mean, well, actually, its main purpose that I wanted it for was to detect a person coming in the room before the camera, or as an alternate to visual. So it can detect movement. Currently it's being used as a motion detector of people, and I may upgrade to the. It can also detect if a person is there, standing or sitting. The newer one can do it better, so it actually can detect heartbeat or essentially detect just a slight movement of a person.
What is this, the Doppler effect or something?
Oh, it's radar. It sends out, it sends out a pulse radar, and it gets a reflection back in millimeter wave radar. So it's the same thing they use for air traffic controllers for airplanes and everything, or your nearby chips to check your speed on the freeway. So it sends a pulse out, and then it gets reflected, and it sees the reflection back, and based on interference patterns, it can tell if something is moving, because the field is changing, therefore the radar signal coming back is altered, right? I'm not a radar expert or claim to be, but if you want to learn more, I should learn more about how radar works, but it's that's the basic concept, sending out a millimeter wave radio wave, and then it interacts with objects and comes back and interfered with, right? And see, it's really cool. They have these available, and there's a few of them. I have a link at the end with the Seed has a family of a line of 4 of these products, and they're all very affordable, and you can see what they can do. Well, the main purpose of this one originally was a fall detector. So if you mount it on a ceiling, it can detect if someone falls. So for safety reasons, like in a shower of an institution or something like that.
Mm-hmm.
So
that's pretty cool.
But in my case, I'm gonna probably upgrade it, because I can upgrade it with the same exact size, and to a better one that can detect people moving or how many people in the room to more subtle degree. So it gives the robot intelligence. That's what I'm trying to use it for. Like, oh, a person is moving. Oh, nobody's here. Oh, person is sitting, or that kind of thing. So those are pieces of knowledge that I want the robot to have and be able to react to in some way, or store in its memory. So that's the idea. That's sort of a longer term for that. And it's cool once you build something like that, and a place has support for those products, and they keep them the same size, then you can upgrade.
Mm-hmm.
So the next thing is the 3D design and printed parts. Were there any more? Is that any more questions on that? Or we good? Move on. So 3D printed parts. I've designed most of these. I had to design from scratch, or at least from and then some of them I took from Thingiverse and modified. So the tray I had to do the tray I did myself, and that's made of multiple parts because that I had to glue together because of my printer volume. And that one, yeah, that was a little bit of a challenge because it has to sandwich the round part of the metal part of orange to secure. But you'll see these other parts. Some of these, like the antenna mount and the pan tilt mount, I kind of took a part from somebody on Thingiverse and then added in merged it with the actual mounting piece that I needed with the right screw holes that I had to create. So sometimes you have to learn to, in Fusion 360, to bring in somebody else's part and then turn it into a mesh and then add your necessary part piece to it and Boolean add them together and merge them, and then you get the part you really need. Radar mount I had to design with a little door there, and speaker base. The Slam Tech, you are charging pile, it's called, and riser, those I did. And the riser is to go underneath the bot back. Then there's the speaker mount, so that the speaker is basically when I put together the robot, when I add a new thing, it is just sitting there kind of loose and sometimes falling off, like the speaker, if you, and so I finally made a base for it and screwed it down, and or at least screwed the base down and put a lip on it so that speaker doesn't fall out. And this Latte Panda screen mount, that was from Thingiverse entirely, so I didn't have to do anything for that one, just print it.
Mm-hmm.
And that's why I adopted that design, that kind of, as Tim might say, kind of an awkward screen with a PC hanging off the back of it, but it worked out pretty well. So here's the cost breakdown. The total $2,100 approximately, or at least as much as I could think of. The top 4 items are there. The original Slam Tech, the chassis, the Delta Panda, and the 2 cameras. Luckily, I got one of those cameras as a prize, but so I didn't even have to pay for one of them. And then the rest is kind of not, under $100 items. And there may be some I'm not thinking about, but.
So are you actually using 2 cameras on Big Orange?
Yes, as you can see back here, this is the top one is for color, is for vision and depth, stereo depth, and identification, classification, all that stuff, all the higher level functions of vision. And then the lower one here is used purely for depth map publishing. And I don't always have that on. They both take up power. So part of this purpose of this platform, the entire Orange project, is really to demonstrate, or for me, it was to demonstrate different components that you could get and do useful things with. And adding the second one here, because I got it as a prize, was the idea to publish the depth map into the Slam Tech system, which already accepted depth maps from the Xbox Connect. So this was kind of a replacement or upgrade to the Xbox Connect. You'll see that in a minute, the history coming up here. where I had the Xbox Connect before I had that Oak D camera, and it was doing the same purpose, publishing depth information in real time for obstacle avoidance. Whereas the LiDAR is used in the system to create the map, whereas the depth publisher is used only for sort of live dynamic object avoidance. That objects that are moving, essentially, that you're not mapping. You turn the mapping off. Unfortunately, what happens is if you leave mapping on all the time, then if someone stands in the same position for 5 minutes, then they become part of the wall. I mean, as far as they become part of the map. So you got to turn mapping off for that reason, but you still need to avoid objects. So you need something else. That's the idea.
So are you using the Coral, the
Yeah,
tensor processor unit?
the Coral dual edge TPU, I initially used that and it's still on board, but currently it's kind of taking a back seat to the Oak D, which does almost all the same things and a lot more, really. But I have a video of that. That's one of the milestones of Orange. Was when it first got an AI camera, and that was it. The TPU, well, an AI capability. It's just you just use an everyday web camera and send the picture to the TPU, and then it will give you back information. So I'll show you that, but I'm not currently using that. I have to figure out how can I use both of those together because it is a separate processor as well, and it could be used for something.
And all this is run off of the Latte Panda.
Yeah, that's coming up. I'll show you the diagram. Yeah, everything's plugged into the Latte Panda. All these high-level sensors, like the cameras, the speaker, the radar. The radar is connected to the Arduino portion of it, and the TPU is in a M.2 slot on the Latte Panda. So that's kind of what's cool, is if you have even a single board computer has a slot that's capable of holding a GPU like that, and it's only like $60, I think, for that TPU. So SlamTech Slamware, that is kind of the core brains of or I'd say the heart of the heart and a good chunk of the brains of the system. The full navigation, the SLAM algorithm is all inside this thing called Slamware. And it also handles the sensor fusion of all the information. So you can have a cliff sensor. I do not have one right now. You can also have infrared sensor and impact sensor. I don't have, so I could even expand more, but currently have ultrasonic, which I'm not really using, depth camera, and then the LiDAR. I should have put in, obviously the LiDAR is supposed to be there. And then you've got an autonomous docking algorithm, infrared beacon or laser feature. I decided to go with the laser feature. I bought some parts for the infrared, but the laser feature seemed a little easier. And I think as far as hardware, I already have the LiDAR and I just had to 3D print that thing. And then it's got Wi-Fi too. So this is all on board that breakout board that you saw. And the Slamware is that little card. And here's a diagram of the system components. So I guess you start in the middle here, that the Latte Panda is where it says Windows and where you have your high level apps, Python, C++. They call it the customer service layer. This diagram was lifted from SlamTech. Above here you have they call the man-machine interface layer, but these are some of the higher level functions that, or hardware that the PC uses, the SBC, Wi-Fi, screen, microphone, depth camera, and other things you might have like buttons. And below this line is the microcontroller layer, the control layer, and that the communication is on Ethernet. So that's how these things are separated. All the communication from this higher level Windows to this this now low level microcontroller systems over Ethernet. And this white square here, or it's silver, in my case, white or silver, that's the SlamWare core. And that has all that functionality we just went over. The LiDAR is connected directly to that, and of course the STM32 is the microcontroller. That's the heart of the board. And like I said, the SlamWare core actually runs a full Linux system, but I don't have access to it. I can't really change it. So it's got their whole system running in there for Slam, and the whole navigation, Slam and pathfinding, and a full API in C++, which I utilize in this layer above here, including with a Python bridge to the C++ API.
Hey, Jim, where's the Panda, Latte Panda in this diagram?
That's right here in the this customer service layer window, where I say Windows. I should have put the word, maybe I should modify this as we're talking, huh? So this is your Latte Panda and Windows right
That's
there.
homework style, building it while you're doing the presentation.
Yeah, this is par for the course, right? In oh, screen sharing has stopped. And what else was I gonna do? Oh, I should put in the LiDAR here. Okay. Let me go back to. So yeah, so that's where it is. Latte Panda Windows is there, and it uses Ethernet to communicate with the lower level system. Does that make sense? And now at the very base, robot base, that's where you have your motor controller, H-bridge, your encoders, wheel encoders, sensors, and well, the motors as well below, I guess, below that even, or it's at the same level, past the H-bridge, obviously. So now a little bit more about what's inside the SlamWare core. And yeah, this system was really a really good launching point for a hobbyist to use, and it took our club a long time to find this product, but it elevates you to a level where you do not have to deal with a lot of things that you might have to in ROS or other type systems, until you want to learn like how to write your own Slam engine, or well, I guess you don't even do that in ROS, but a lot of the integration here is extremely convenient for these really advanced software implementations that you do not have to do yourself, including the LiDAR system, the D-Star engine. So a lot of this is what in ROS, what you would run the cartographer and then the your nav2, right? And the D-Star engine is more, it's a dynamic A-star. So you might be familiar with A-star planning algorithm, which takes where you are and where you want to go and an occupancy map and figures out a path. So D-Star is a newer version called dynamic A-star. So then you have these different things, the SLAM engine. Now you have your IMU, and then the RP LiDAR, etc. And then
Jim,
yeah.
what do you use the IMU for?
Well, I don't even have to. I don't really use it directly. This system uses it internally for helping helping navigate to tell it where it is, essentially, based on. Yeah. So that's more of an internal to the Slamware. But
If it was to fall over, would it know it? Would it stop and say, "Help! I'm falling over and I can't get up"?
Yeah. Well, like, remember I said it had like impact sensor. It has the ability to, if it's impact, if it hits something, this DOF might, that could be triggering. That triggers a message from inside Slamware core, and tells the microcontroller or even Windows, whatever, that something's happening. I don't have that hooked up right now, so
it probably helps it drive straight.
Yeah, this is, for as far as I'm concerned, I don't really use the IMU directly. It's used internally to keep it driving straight and that sort of thing. It can, and maybe also for when you impact, if you hit something or if you can't move, although I think that the encoders are good enough for if the robot gets stuck and the wheels are spinning, then the encoders are going, but I mean the encoders are not, the robot isn't moving forward based on the map and the LiDAR. And maybe they use the IMU in there too, though, just like the robot's not moving and the motor is turning, then something's not right. But yeah, then you have on the right side the pose of the robot is figured out in the map, and the mapping all comes from this. So yeah, the IMU is definitely used in there. I should learn a little bit about that. Well, again, it's something I don't have to worry about, so I focused on higher level issues, but the Slamware documentation may say something a little more detail about that. But it certainly helps get you your X, Y, and theta, which is very critical to all my high level functions. The pose, where is the robot, And here's more detail about it, about the autonomous position navigation system. So it uses that RP LiDAR, and that is sending out, sending out laser, measuring constantly, and the SLAM is running, taking in that data, and then forming the map. And you can run it without making the map. You can start navigating without a map, actually. Just as soon as you turn it on, it creates a coordinate system and it maps where it is at that moment. Just kind of like you see here, it just starts mapping, and you could give a coordinate outside of its mapped area and it will start going in that direction and keep mapping as it goes.
Hey, Jim, typically in ROS, you create the map, you save the map, and then you navigate within that map that you saved, the static map. Do you do the same type of thing with SlamTech, or is it continuously, simultaneously mapping and navigating?
Yeah, well, like I said, I've done a video, I've done a demonstration of continuous mapping, as well as most of the time I save the map and use it. So the answer to your question is both. It does both. It can map as it goes. You can turn on and off update. Even on my robot here, I can tell it start updating the map and stop updating the map, and then
Okay,
save the map.
To my knowledge, that's something you can't do with ROS because it's either the, static mapping off, or, you're mapping while you navigate. And the problem there, of course, is if you get delocalized a bit, all of a sudden your map is whacked and
Yeah.
and you forget about it.
I've seen that happen. This system has a lot less failure or a lot less distortion of the map than I've seen so far in ROS, but we don't even know what they're using in here. They could even be using ROS in that black box.
Might it be Hector Slam?
Well, it could be. They don't ever mention the word Hector, but the other thing, I think ROS can do dynamic mapping and navigation, but
It'll dynamically path plan around something in your static map.
right. But I mean, yeah, I guess I don't know. Maybe I'll defer to you, but
If I leave the mapping on and it gets tweaked, all of a sudden the map goes to hell.
right.
So
But
you create a map and you basically navigate within that static map, and it can path plan around dynamic or moving obstacles within the map.
right. But I mean, if you didn't have the problem of the map tweaking, then theoretically it could map as you go, and you could just like.
That's the goal. That's the goal, is lifelong mapping.
Well, that's totally been done. I mean, Shiloh wasn't on tonight, but Shiloh did that as an intern project 5 or 6 or 7 years ago when
Yeah.
right. And basically it was ROS, and basically I can't remember which SLAM package they were using, but it just continuously published to the map topic, and the navigation stack was able to respond to the map. So it was not a static map. It was doing it was growing the map dynamically.
Yeah, I know ROS can do it. It's just, and remember Steve McKenzie's talk. He was quick to say, yeah, it can, it should not, if you're getting tweaking of the map, then that can be fixed. It's not like, it's not impossible to fix that. And I would like to find out how. Maybe I'll email him.
I found SLAM Toolbox to be better at it than G mapping, but again, for lifelong mapping, it's not working for me. I'll say it that way.
One of the things you discover when you start doing the dynamic mapping is the robot, doesn't intuitively know about its own configuration space, and it doesn't know about no-go regions. And when Shiloh was doing this project, the robot had a planar LiDAR that was looking 6 inches off the ground. So it would like try to drive under desks, and it drove into the shower in the men's room, and things like that.
Oh yeah, it's going to do all that because the LiDAR doesn't. If it's just the LiDAR, it only knows that one level of information. So but the point of this system, what I like about it is I can plop it down in a new room, a new location, and I can just click on the map where I want it to go, and with my own eyes see that it's safe, and then the robot will just start mapping. In fact, I could click on several points in the map once I get the bearing. Once the initial area is of the robot where it's standing there is mapped, then I know kind of what where the empty part of the map is in real life. So anyway, but it's kind of a cool thing. And also, if you use what I have built in here, the following mechanism, then I can just turn on the robot, say, follow me, and walk it around the house and map the house for the first time. So that's, then you don't have, that's almost like remote controlling it though, I suppose. But it's not quite that. It's actually seeing where I am and setting a goal right behind me, and then every few seconds. So that it's making the map as it goes. But yeah, I already talked about this pathfinding with D-Star. 5 centimeter resolution on the maps. Light well, yeah, it only needs 5-volt power, which is pretty cool for that part. And the RP LiDAR. It does eat up batteries, or I mean, it takes current though. So here's the SDP mini breakout board. This is the core, that I call it the heart, whereas the Latte Panda is the brain. This is the heart of the system. And this came with that SDP mini. That was its heart. And you see here, you've got GPIO pins, you've got motor IO, you've got the sensor IO, and I'm not even using all of it. It has IR sensors, ports, as well pins, as well as the I think cliff sensor somewhere. Actually, I don't know if that's marked. And then the core. So that's this board, and this the source code is, there's the Ethernet, a little buzzer, there's a little beeper so you can hear it. This is completely open source software, except for the Slamware core, but the rest of it. And well, and here's the full. This is the full kind of layout of the system, all the components. And I tried to update this, and I'll publish this whole stack on, so you can read this later, the whole stack here. But essentially, you have your Latte Panda in the middle here, and you have your Slamware core system breakout board here with the core, and then various sensors, battery, charging station, charging connector, displays, wireless game receiver, battery monitor, bumpers, speaker array, the motors, everything's there. The key interface here to the PC is the 7-port hub, powered hub with a lot of things connected. And then you have, yeah, forget about the Arduino Leonardo is part of the window, part of the Delta, the Latte Panda, and then it's got Bluetooth, of course, as well. So a lot of stuff here, but this is sort of the breakdown of all the components. So now I'd like to talk about software. Any questions about hardware before we move to software?
Just a comment. I've just put in the chat a link for the HCR mobile robot platform. What does that stand for? Home care robot or something?
Home care, yeah, home care robot.
Yeah, it's currently priced at $630.
Yeah, well, there's 2 of them. I think there's one with Omni wheels and one with the regular, and I have the one that comes with more parts.
Yeah, the link I put in are the regular wheels.
Yeah, well, that 600 one might be with a few more parts than mine came with, because I think it might have a motor controller with it or something.
Well, there's inflation now, you know.
But it might have gone up. That's true. Yeah, so that's, I mean, you know, these aren't new. They're kind of old. And the drawback of the pancake style shelf robot is you have difficult time getting to the lower levels without taking apart the upper part of the robot. So got to have small hands or leave some room in there, because it can be a pain. But I've had to take it apart a few times to redo stuff in there. And there's other styles that are kind of a little more modern now that allow you access. I think like a step, some people have like a staircase style robot where it's on little levels that are all accessible or something like that. So the software, the Python application is the top level brain and functionality that runs on the Latte Panda. There's submodules for many functions of sensors and the voice system. Below that, you have the SlamTech DLL. What this is a C++ binding to the Slamware API. Or I mean, the Slamware API is in C++, and so this is a library that is friendly to Python. So it makes Python interfacing. It makes an interface that Python can understand with the types and all that functions. And so all these functions are the functions that are exposed in the DLL can be called directly from Python or C++. It doesn't matter, but Python is kind of particular, of course, about what types you can pass and that sort of thing. Now, the SlamTech STM32 breakout board firmware is the next level. That's the lower level. That's open source C++ code, and I reconfigured it for Orange's system. Well, not just the motors, but pretty much all of the, mainly the motor, and then battery code for monitoring battery level, and charging, the charging system as well. So I had to reconfigure that, which is cool. So you can reconfigure that for any robot that you adapt your SDP mini system to. And that could be, and there were at least five people that bought this in our club, 4 or 5, and they built their own robot based and reconfigured did the same thing I did, except with completely different looking robot. Some of them like 6 feet tall, or well, 5, or at least 5 feet. So the next is the Leonardo controller. That is, I loaded onto it what's called the is a standard Fermata, and I modified it for Arduino. Fermata is this nice, nice serial messaging system or program, client server that you can if you have a serial port handy on your in this case on my PC on the Latte Panda, and it's the Arduino is essentially built into the chip is on the board, so there's like a dedicated serial port that you can communicate with the Arduino. And so the standard Fermata handles the server side on the Arduino, and the PC, I run a client in Python, and that controls the OPD and servos and the radar. So I can control those from Python on the PC. And in the future, more possibly more things on the.
So is the SlamTech running on the Panda Windows, or is it running on your controller board?
Well, this is running on the SlamTech stuff is running on the STM32 breakout board.
Just the controller board, yeah.
That's a controller.
It's,
we call it the break. What's that?
The heart, not the brain.
Yeah, that's the heart. So that and then within it's a little complicated, but within that, this is the STM32 breakout board that has a Slamware core running a complete Linux system that handles many high-level functions that you communicate over Ethernet, and it also houses the STM code as well, which is open source. This is closed source. This one's open. And that's the one you need to handle all the sensors and everything, all the to control the motors and everything like that is, as you can see up here. Bumpers, STM32, sonars, STM32, battery monitor, and the motor controller. Where is my motor controller? I've lost it. Oh, I guess that's right here. Oh, there should be a little line here that connects the motor controller to the breakout board or to the STM. There should be I should now you've found a little missing piece there, but the obviously motor controller is connected to the STM32 board. Does that make sense? This board handles your motor controller level and your I/O to the main sensors of the lower level robot, essentially. And then
What do you use for motor controllers?
the motor controllers, this one, there's two channel 15 amp DC motor driver. That is also from the one I bought. I don't know if it's still in production, but it was from the DF Robot. And you can see, well, I guess this was a picture of it right here. So it's a DF Robot product, and they have a few different ones. But they're, as long as you get one that can handle the motors, you're fine. Something that can handle the power requirements. But this is a basic motor controller, and even it has PW. It's a PWM. It can have a directional signal for each, clockwise, counterclockwise for each motor. It's 12 volt, handles 12 volts for 12 volt motors. It even has an overcurrent pins. I'm not using them. That would be a future kind of little mini project to add in the overcurrent system or something. I've kind of, not done that yet. I haven't really focused much on safety, which you can criticize me for later, but yeah, that answered your question, hopefully.
Yes.
So Leonardo controller. So this is serial port, like I said before. That's how I access that. Now we're getting into PC applications. The DepthCam Publish is a C++ program that runs on the Latte Panda. I guess I should have put that there. Publishes depth maps to the Slamware core over Ethernet. That's how everything gets to Slamware core, it's over Ethernet. The PC is directly connected by Ethernet to the STM32 breakout board, and that's how they communicate. And it also has Wi-Fi on there. So, but I don't use the Wi-Fi anymore because the PC is on board. So when you had the SDP Mini, you could have a PC and connected to the robot via Wi-Fi because it has Wi-Fi on board. It's low level on the SlamTech system. But when you buy the SDP Mini, it's got no PC on there, no high level, just a low level microcontroller and Slamware core. And then the last one is the manual controller. Program reads the game controller input and sends move commands. So that's how I use an Xbox or whatever, a game controller, and drive it around. So here's a view. What are you doing on time? 8:45. Try to go a little faster here. This is a top level, because you could read this offline. This is the software, sort of I did as best I could a diagram of the different components in the top level app that I've worked on. This has taken the most time really of any part of the system, is the software top level brain, really, including the pieces that support it. So you've got moving the camera, radar, display, including the eyes, the text to speech, the speech recognition, all on board. I don't use cloud for any of this anymore. Facial recognition on the well, that uses the camera, of course. Human pose uses the camera, but these are all submodules. Object recognition, as you can see here, uses depth AI. Depth AI is the base system of the OAK-D stereo cameras. Speech recognition is done with this Vox, very popular, very good system that I adopted recently. Windows SAPI is used for the text-to-speech. Pygame, as Scott also uses for my display. PyFormata, as I just was talking about, this is the client side that talks to the Arduino Formata on the microcontroller side. So this system has two microcontrollers, one on board the Panda and one on board the Slamtech. And then you have things like the pixel ring and the microphone array. And this is a very important part, although it's not exciting. It's the Python to Win32, 64-bit to Win32, which was rather critical because this old software is 32-bit and it's not operating. This is part of the downside of Slamtech. The support and the upgradability is very limited, and they do not. I don't think they even. Well, at least for mine, it's not 64-bit. It may never be. And then below that, at the bottom level here is the SDK to Windows SDK, and this whole unit here talks to the lower part via Ethernet. So all the commands in here create Ethernet packets, essentially, send it on down, and it gets interpreted or it gets received by the Slamware core. So here's part of the runtime. Threads always running and threads that are on demand. So voice and recognition, that's a thread that's always running. Display thread always running. The OAK-D is running something, either YOLO, MobileNet, facial recognition, pose. Go to location is always running, ready to take on a new goal, and then time thread. Now these are high level, like this go to location gets a message sent to it. It's a really primitive message. A variable gets set. You can call it a message. You can just call it a global variable in my case, but then the go to location, this is all in Python, the whole thing here. Then it issues a Slamtech command to go to a coordinate once it figures out the coordinate for that location. So and then Slamware, sorry, then the whole planning starts happening and all that. So this is but this has a lot of logic in it to handle things like delivering things to people and all that really high level logic where it's multiple steps to, it's not just going to a location, it's going, it's going to, it could be doing several steps or multiple locations. So here's a sampling. This isn't all of them, but well, this is all, I think, most of the movement commands that are a voice or text, including this one was this was the HBRC Floorbot Challenge #1. Go across the room and come back, and that one actually uses the LiDAR, finds the longest distance to the furthest wall, and then sets a goal to that point, and then back to where it was. Go recharge, go to dock, go forward, backward, et cetera, go to location, recover localization. That's a special implementation inside the Slamware to try to relocate yourself if you're lost. Load map, save map, clear map, map updating, speed. These are, update location. This is very convenient. You can drive the robot somewhere and say, okay, this is you can save a point. You just say, this is now location 1, and then it will save that. And then later you can say, go to location 1, and it will, or whatever the name is. Did I list that twice? Yeah, I have to delete that one. So now these are the complex ones that I work very long. Each of these took a lot of effort. Find the object in the whatever location. Take a picture. That was a slightly easier one. What do you see? This uses the Edge GPU. You'll see there's only a couple of commands that use the Edge GPU. If I have the webcam, and actually I'm going to upgrade this so that it uses the OAK-D. So the OAK-D will be forfeiting its own AI brain and sending it to the Edge GPU. That'll be interesting. So you can introduce yourself. I am so-and-so, and it does facial recognition, facial memorization, and then later recognition when you say, when you just say hello orange, and then it will look up at you and recall who you are. Oh, that's this one. Hi, hello. Take these objects to one or more names in at location. So that engages the whole identify the object you put on the tray, and then go to another room, find a person. None of these use the facial recognition except for the one that says that. That's an improvement I'd like to make, is so that you can say, take these to Jim or Camp in his office, and it will look for Camp and not give it to anybody else.
Question. I know robot I use Koki as speech to text because Vosk wasn't supported on the Jetson. And one thing that I've realized it does real poorly is any proper noun. So if I say I am Scott or my name is Scott, it doesn't pick up Scott correctly. How do you find that Vosk does?
Wait, what's the other one you use that didn't do well?
I use Koki speech to text, which does well for non-proper nouns, but for proper nouns, it's really terrible.
Yeah, no, it does really well. I mean, I was surprised. It has a very large dictionary. Even the Vosk runs in a 50 megabyte. It's a 50 megabyte file. That's it for they call it a small model. Although it expands to 500 meg, I think, once it's deep. Maybe it's compressed or something, but
sure, the
file is only 50 meg versus gigabyte, versus like the other ones are a gigabyte or 2 gigabytes.
Yeah, I'm gonna try it.
Vosk, I've given it like Abner, Doubleday, and I've tried really weird names, and it seems to get almost every one. But there was a problem with that. Well, the problem, that's like a side topic, but I had to do a little more, not a heck of a lot, but a little more work to sort of seed Vosk with this command list as I had to essentially do what they call a merging of language models. I made a tiny little model with my command list, and I merged it into the big English model with a percentage, like 95% theirs and 5% mine or something like that. And therefore, then I could utilize all of the words they have in all the proper names they have in there. But if I tried to tell their system, I just, these are my commands, and I didn't do that merge, then I'd lose all their functionality. It's a little hard to describe, but essentially you had two choices with Vosk. You could tell it, here is my limited vocabulary or whatever commands, or use the whole thing. But then if you told it use the whole thing, it didn't get all your it got confused, it got multiple answers and may not get your command right, might get it slightly wrong. And so I wanted to seed it for the exact commands. But if you do it the first way, which is just essentially override and say, these are the commands, then it doesn't have any of the names anymore. So I thought, is there another
Right.
way? And yes, there was another way.
You guys are throwing around an acronym there. I didn't quite.
Which one? VOSK?
Well, what's it called?
VOSK, VOSK. That's
Thank you. VOSK. Thank you.
VOSK is right here, VOSK. It's on the internet. You can look it up. It's really quite good, made in Russia, you know, but the guy is really helpful. The guy that runs it, or the team, they're very responsive. You know, I mean, they can't spend much time with you, but you get quick answers, but they're accurate enough. If you do your homework, you'll get what you need. And so, but that's an interesting, it's an interesting thing. I could, you know, that I could talk about more another time. But yeah, basically, I really like VOS. It can handle a lot of proper names. And
I posted a link in the chat.
you can also, what I said is recompile the graph on a PC, on a powerful PC, and add in your command list. So then when you say recover local, you know, when you say go to dock, it doesn't think go to duck, you know, or because what happens is some of these words or these phrases, it's gonna get one word wrong, and then like duck instead of dock, and that, you know, ruins my command system won't take that. So you need to tell this, you need to sort of bias the language model with your specific commands. And that's what I mean by merging. So there's this merging of the nice big fat English model with your command list. And that takes a little effort to set it up, but you can what's called recompile the graph of the other.
Looks like Scott's got his hand up.
Oh, I'm sorry, I can't see everybody. Oh yeah, I see it.
That was from before. I'll take it
Oh,
down.
there you go. So did I? Yeah. So the complex ones, right? All these ones, all the way up to the track me, follow me, come here, and the newest one, go there, pointing to a place on the floor. So those are the top level, and I'm still trying to think of more to do, but I think I'm gonna, like I said, go back and fix some of these ones that say take this to a person, and if there's two people there, it should find the right person now, as long as they're in the system. So now this is the kind of getting closer to the end here. We're gonna the namesake of this lecture was the origin and chronology. So here's what it was, the beginning in February 2020. It was just an Arduino controlled motor and wheels. Then I was working fast at that point. March of 2020, it's now SlamKit controlled, so the base system. By November, I called it V2, and it had a screen and the Xbox Connect going for it. V3 was 2021, March of 2021, with the now OPD camera replacing the Xbox Connect, webcam for the TPU, speaker and microphone built into this thing here. Then V3.1, they added the cargo tray. V3.2, the depth map came, the second OPD came in. V3.3, it got the eyes, software really. V3.3, oh, I guess same time. Oh, wait a minute, that should be 3.4. That got the speaker array. And then V4 is current 2020 with everything in the right positions now, or the current positions. And we'll see what happens. So, well, you probably don't have time to do any videos, but I've created a highlight reel of the, I have to do new share and then say this. Yeah, you see, it puts a nice little green border around what you're sharing. So this is now the, I call it the orange milestones. So I'm gonna just show you where it started from.
Okay, let's see the maiden voyage of this robot. I'm gonna turn that on. You can see the screen.
Is this playing smoothly enough?
Let's make it go right.
Yes.
And left. And left. Pretty fast. Let's try forward. That's pretty fast.
So that was the beginning. That was the very beginning of Orange. And you know, over the time it how do you close this thing down? So yeah, these are like, I picked 14 videos out of the 47 or so. But the very next one, it was a Slam Tech robot. I guess I'll just show like a few right now. So this one, I turn it on. And
Orange, rotate right 90.
now it's taking voice commands and
Rotate right 90.
I kind of look back at this and when it was using the Windows SAPI and the voice recognition is split fast.
Orange, rotate left 90.
Okay, rotate left 90.
That's just Windows SAPI and a list
Orange.
of commands.
Go to living room.
Okay, living room. Moving.
So if you really have a very limited set of commands, you could get rid of all this language model stuff and use something like the built-in Windows SAPI, and it works quite well. Anyway, so that's well, that's that level. And let me make this smaller. And then, yeah, we get into, and then you can fast forward Orange, then the HBRC floor challenge I put in there. Or, well, there's V2, version 2 was kind of a milestone.
And a game.
Where it's, yeah, there it is. With the Xbox Connect. Oh, sorry.
I'm now connected to Slam Tech.
So that's what it looked like then. And this is the Coral Edge was.
Okay, so here we go. Now I've got a picture of a bird, which I have a model for. So
So this is using the Coral
ask
TPU
about,
and a web camera.
Orange, identify this bird.
Kind of shove it in its face.
It looks like a Cooper's hawk.
It said Cooper's hawk.
The last time it said red shoulder.
So that uses
look.
That uses that TPU.
Hey, Jim.
Yeah.
I have another question. So are you, you said you don't have like a wake word system built in yet, but I know you have it wake up when it hears the word orange. Are you just constantly taking the stream and just transcribing everything?
Yeah, that's why I really like what you've done, or I mean, what you were pursuing with the wake word from the that I forget the name of it right
From
now.
Mycroft.
Mycroft, yeah, and I was happy that somebody's moved it to Windows, but I listen to everything, and if the sentence starts with orange, but then I actually just modified it recently so that it looks for orange even in the middle. Then it like strips out whatever was in front of before orange and then assumes that's, and that actually works a little better now because if other people were talking, well, and then someone starts a command, all that could be in one capture. So it might be, and thank you, Jim. Orange, can you do this? And then it sees the thank you and it strips that out because it sees orange. And then anyway, but everything is being transcribed and it does eat up some CPU power, and that's just not necessary. So that's why I really want my next thing. Not only that, actually, one of the biggest downsides of not having a wake word is that the robot is constantly trying to figure out or thinking that it might be given a command, and therefore it's delaying while it's processing so that you can't give it a command at that point. So I have this little I have the little pixel ring rotate, giving a thinking pattern, and it's always thinking unless everybody is quiet and then you give it a command. Well, if no one is saying the word orange and you're using a wake up system, then it won't be thinking at all until it hears orange. Then it will start.
Right. Now, one thing I'll just caution there is that the wake words, one of the problems, at least with the precise, the Mycroft one, is that you do the wake and then you have it do something else, but there'd be a delay, right? So you'd have to do like, hey, orange, and then it would detect it, and then you could do something else like that. But it's not set up such that you'd be able to be like, hey, orange, come over here, like you can with Echo. So that's just one thing to keep in mind. It's one thing that's neat that yours that Orange handles now is the real natural way you're speaking.
So
what do you use for a voice synthesizer, Jim?
Yeah, mine is just using Windows, really built-in Windows SAPI, which is the speech API, and it's in every version of Windows. I ended up kind of don't tell Microsoft. I used an online hack to use the David voice, which is a little bit nicer than the standard voice you get, but it's all in there. And you can buy voices for SAPI. I mean, it's still a supported product.
So it's the Panda talking.
It's the Panda talking, yeah.
And that's only available in Windows, though. So if we're running a Linux system, it wouldn't be available.
I just use that for convenience. There's a lot nicer, text to speech systems, a lot more varied and whatever, and more advanced ones that sound more human-like. Or you can use cloud, certainly, and get very human-like cloud-based. So that's up to you. Yeah, but I use it's in Windows, and I'm going to take advantage of stuff like that's in Windows for this robot anyway. But yeah, I guess the wake up word, it sounds like it won't be quite as good as Echo. You have to say orange, and then it'll, what I'll do is you'll say orange, and then it will light up when it detects it. Then you know that you can talk.
Yeah, yeah, something like that. And another thing to keep in mind with wake words that I've always been told is that you want to do 3 syllables, which is why it's okay Google and hey Siri. And I haven't gotten, I've always thought, I wonder if I could get away with just 2 for robot, but it's another thing to keep in mind.
Yeah, right. Yeah, I forgot about that. Yeah, I haven't dug into that, but Orange may have to get a nickname, like, or just say Big Orange is 2 at least.
Big Orange is great.
At least
problem with robot is it sounds too much like robot, and
sure does.
Problem.
Wayne got his hand raised.
I don't want to derail the speech recognition thing, but the question I have is This
No.
sounds like a pretty complicated software and hardware stack. Do you have any insights into how you debug this stack? Because that's got to be challenging as all get out.
Yeah, that's a good question. I tend to work from the ground up. Like the other day or a couple weeks ago, orange stopped turning left suddenly, and I was in the middle of doing point to goal and go behavior. So I'm like 7 levels up, and like a girder broke down in the basement or something, you know. So, well, I don't know where it broke. Could have broken anywhere, right? I had to like figure that out. I'm like, well, what's going on? And so luckily, you know, something like that, there's a hardware pin for that. Like, well, first of all, you figure out, well, one wheel can't turn backwards. And then I went back from there back to a pin that says the direction of the wheel, and then which wheel is it? And then upwards from there. Eventually that problem was really a burned out IO pin. So I had to switch to a different pin. And, but with debugging from the software stack, generally what's nice about the Slamware stuff is that stuff works. That stuff is pretty well debugged. If go back to like this, so the Slamware stuff down in here, this stuff is pretty reliable. It's a commercial product, so that helps me. And then, so in that case, then I really need to debug. Well, if I'm working in the main stack, which is not simply, but it's the Python code, and then a submodule, and then an underlying module, and then perhaps it may end there. So I'll generally, when I build one of these things, like I say I add speech recognition, or recently I changed from to VOSC from something else. So I just add in the VOSC low level, and then I write a test code. So I have like test programs for every single one of these features that didn't involve the robot. It just tested the one feature. So that's kind of how I work. And then if there's bugs in that, I won't move forward until I get that figured out and get it to the point where then I can start integrating it into the main. Main is pain because you might have to launch the whole robot, but I also have partial launching capability. So or debug mode, let's call it debug mode. So I run the main Python app, and it doesn't really run, it kind of goes into debug. It just does some initialization and then leaves you at the idle, at the prompt. And then you can start issuing Python commands. So that's kind of what I do from this high level is I'll turn on the robot, start up the software, but it's not running the main loop or anything. It's just initializing and setting up. And then I do one thing like debug facial recognition from the ground up using just like actually typing commands to Python, stuff like that. If it's lower level than that, like if it's in C, then it's more like print statements. And if it's in the firmware code, that's the kind of the hardest, because that's but there is a way you can print debug statements out to the serial port. And that's, for instance, this is the serial port from the Latte Panda to the breakout board, to the microcontroller. So there's a path there to get. So I would say what I just said before, the whole taking it one step at a time from the bottom up, and also using a lot of printfs, because you're not gonna, I almost don't use any breakpoints. There's no really way to do it. Mostly in this system, like source code debugging or source code debugger. So it's a lot of the old-fashioned printfs and and doing one step at a time and writing little test cases. Does
Okay.
that sound good?
That sounds good. So the summary is lots of print statements, and then you have a stack of unit tests that you keep around so that you don't have to keep reinventing the wheel. Is that a good summary?
Yeah, and I make a new test case for each thing I'm adding.
Okay.
And test it from the most basic function first. Oh, also, for instance, with the sensors, I will get an Arduino Uno and like connect the sensor. Like for instance, the radar here. I'll run if I get a new sensor, like any of these things, and all of them really. I connect it to the minimal computer that will run it, and run all the sample software, and test it and understand everything before trying to integrate further. So that's sort of like a prototype or a hardware test and understanding before integrating any sensor into this big massive systems. Because if I debug that first, then I know, well, it's probably not what I already tested. That's not working, right?
Okay. No, thank you. That was very informative. I'm always concerned about these big systems. They become almost intractable to debug.
Yeah,
So
it is. It can be a pain. It can be a pain, but you know, and I don't claim to have all the answers, but I try to take a vertical slice, let's put it that way, and debug that. So
go on to the next question, whoever that may be.
Yes. Okay. Are we here? Let's see. Well, it's getting late. I want to wrap up. So yeah, I know Scott had asked about this. Some of the challenges in Eureka moments I had were, well, I call it Eureka moment because I felt like I figured out something. How to detect if an object is really there using the camera and all that, using the AI. I had to integrate over time using a kind of a software filter, resulting in a percentage of time the object is detected. Unfortunately, in most of these systems of neural network models that are in vision, you'll see a classification of an object, or what they call a detection, where it's got the bounding box. The bounding box will flicker on and off over the course of a second or 2 seconds. Is the object there or is it not? If you take one frame of video and try to decide if the object is there, you're going to be your sampling rate is horribly too low. So you have to integrate, and I found that kind of challenging, and it still is always it's still an issue that you have to deal with on any of these, but there's a solution, which is to kind of look at, accumulate, and see what percentage of frames the object is detected, and if it stayed the same object, you know, and that sort of thing is it's a problem with all robotics, I think, and all sensors that show a brief, you know, that show an instantaneous information, but what is it in real life? We as humans, we integrate over seconds, not microseconds, you know. So in a computer, you have to program that in, unless somebody else did it for you, which is the case with my radar. The radar is really nice. It's built into the hardware, or somewhere in there, that it tells you somebody's moving or there's movement. You don't have to do this low-level code, but that's not the case for the Oak D camera. Then how to build a docking station and docking connector. That was a challenge for a while until I bought the Nito bot back, and I kind of immediately moved Orange next to it, and I said, oh, this could actually be the right size. And then I had to figure out how to print the charging pile, and the charging adapter was the hard part. And then how to make Orange follow me. It was like, I always thought, oh, this is so hard. And then you know, I got some help from Scott Horton, and then it just piece by piece, it was like, first track the human with the camera, which you can do. There's sample code to at least identify a human, and then you have to kind of deal with the tracking, moving the servos, and then setting goals in the map based on the depth position of the person, and eventually it builds up to a follow me. I mean, Scott, the other Scott here, has done this as well, to follow me, but it's not as hard as, it's not as intractable as I thought it might be. So here's the wish list. Take these, well, I already told you this one, specific, take an object to a specific person identified by face. Dance with me using the human pose detector, so it kind of does mirrors the movements of in some way or another. Like if you go back and forth, you twist, then the robot twists. Notify me if anybody comes in here. You could use the radar for that. Map the room automatically, map the house automatically. Where is my phone? Remembers locations of things. So this gets into the whole memory. Someday I'd like to do that. And then I already told you about the wake word listener, and now we know the caveats. And then more complex commands with facial recognition. Well, I think we already covered that. I'll save this for, you know, you can look at this when I put the deck up on the internet. And but these are links to hardware, links to hardware, to how to build some of this, like what I was inspired from, or what helped me, you know, using this HCR and the Slam Tech. There's 3 blogs. And then the neural networks I use on the OAK-D, Tiny YOLO, spatial info, mobile net SSD with object tracker, facial detection network, which is 3 different things running, Google, and then the Blaze pose. So, and this is like, this could grow. There's so much you can do with that camera. And finally, thanks and credits. Dr. Bruce Weimer, he really got us introduced to Slam Tech and the AI SIG, and he gave me Python code to get me started, the main code. Gary Malopsy, he had the initial version of Slam Tech DLL. So this was an Alex Brown, the microcontroller reference code. He started, all these guys built their own robot. John Davis, with the same system, John Davis did too. Brian Erickson helped, and Carl Sutter, when we did the competition, open CV AI competition. We were called the social distancers team, and everybody else who I'm not naming here. That is it.
That was awesome, Jim.
And sorry, we're getting late, but
it was awesome.
Excellent
Totally
as usual.
fun. Quick questions, anybody?
What are you out of pocket now, Jim?
Well, that, like I don't know if you were there for the cost breakdown was about $2,100, maybe $2,200 with extra things I'm not thinking of, but pretty affordable.
Yeah, I had to step away. Thanks.
Yeah, the cost of it, honestly, for this capability is probably, you know, pretty decent. It's the matter of, it's the hours you have to do to, it's the sweat equity is a bit higher than, quite a bit higher.
How many hours do you have invested in it, roughly?
Well, I mean, yeah, it's a lot. It's like probably, you know,
4,000?
What is it, 1,000 hours is what, like 41 days or so, or well, like if you say I'd work on it like I mean, over the course since 2020, it's probably a couple thousand hours. But you know, I work on other projects too, so things kind of move fairly quickly with it, and then I stop and do something else.
You have a day job too, I understand.
Yeah, I work pretty quick and try to cut corners as much as possible. I'm not doing this as a product. I copy paste, but I also I read the code and make sure I understand it.
Any more questions? For Jim?
Yes, all right.
DiNunzio, very good. And Big Orange. Big Orange is there, right?
Yeah, oh, sorry, let's switch the camera to live.
Big Orange live in person.
You see it? Oh, there it is, yeah. Oh, it's not in focus.
Thank you very much, Jim. This has been an awesome presentation.
Thank you. I hope everybody enjoyed it. If you have any other questions, feel free to email me or otherwise communicate.
Very inspiring.
Yeah, thank you for your support and listening to long talks about this.
Well, you know us. Okay, thank you very much. So we have an HBRC business meeting on November the 2nd. And Ross discussion group on Tuesdays, voice intelligence group every other Thursday, the builders SIG on penultimate Wednesdays. Join the mailing list, tell your friends. If you're into building robots, this is the place to be.
Yeah, and we'll be sharing slides.
Yeah, get them to Al, post them to the mailing list, but we'll co-opt them and get them into our meetings archives.
Yeah, and yeah, sure thing.
Okay, thank you very much, Jim. That was awesome. Jim DiNunzio, ladies and gentlemen.
Thank you, everybody. Thank
All
you.
right, so I motion that we close this October meeting, the HBRC. Do I have a second?
Well, do people want to linger around and discuss things?
Yeah, we're gonna.
We don't need to. We can stop the recording.
I'm just closing the official meeting, and we'll hang out in the parking lot till security kicks us out. All right, meeting closed. Now we're into random access. We're out in the parking lot and we're waiting for security to kick us out. Thank you very much. Thanks everybody for coming. We had fun.